Welcome back to our math class differential equations. So I hope all of you are doing well. So today we are going to discuss exact equations. So what is exact equation? How to solve exact equations. So let us start. Say f first order differential equations m function of x y dx plus n function of x y dy is equals to 0 is called exact equation if and only if partial derivative of n with respect to x is equals to partial derivative of m with respect to y. So how we choose m, how we choose n? When we see here dx, then the coefficient of dx, we find the partial derivative with respect to y. Similarly, the coefficients of dy, and we find the partial derivatives with respect to x. If these two results are same, then we call this equation is exact. Sometimes we get the equation in this form dy dx equals to function of 1 xy function of 2 xy. So now we can write this equation in standard form. In this case, if function of 1 partial derivative with respect to y is equals to negative, because of this negative, function of 2 partial derivative with respect to x. So same as this. Now we will discuss how to find the solutions. So here I give you the working rules. So first we choose m in the step 1. Then this m we integrate with respect to x, because the m is with respect to x here. Where we consider y as constant. Step 2, we find out the terms in n which are free from x. Then we integrate that terms with respect to y. If there is no terms with respect to n, then we consider that is 0. Finally, we add these two answers and consider them equal to an arbitrary constant. So in the next slide, I will show you one example. Let us consider these examples. Here we can say m equals to cos of x plus ln y. We say n equals to x by y plus e power y. Since it is coefficient of dx, we find that the partial derivative of m with respect to y. So here the answer is 1 by y, because cos x, we consider x as constant, so the derivative of cos x is 0. Similarly, here we find the partial derivative with respect to x, consider y as constant. So here we get this is 1 by y, so this is 0. So now we can say that del m del y is equals to 1 by y is equals to del n del x. So the equation is exact. So the equation is exact. Now we will solve this exact equation. So to solve this exact equation, first we find the integration of m with respect to x, considering y as constant. So step 1, integration of m with respect to x. So here our m is given cos x plus ln of y dx. Here y considered as constant, so the answer for this one is integration of cos x is sin x plus integration of y is x, so x ln y, because y is constant. Similarly, step 2, in n we have to find out the terms free from x. So this is our n. Here this is the only terms free from x, so now we can find the integration of that terms. So the integration of e power y with respect to y is equal to e power y. Finally, our general solution is sin x plus x ln y is equal plus e power y is equal to arbitrary constant. So this is our answer. So in the next slide I'll show you one more example. So in this example the question asks, show that the following differential equation is exact and solve it. So we have to rewrite this given equation in a standard form. So we can say minus 4x e power y dx is equals to 2x square e power y minus 1 dy. Now we have to write it in standard form. So minus 4x e power y dx plus 1 minus 2x squared e power y dy equal to 0. Here we bring these terms in the left side, that's why the signs are changed. Now m equals to minus 4x e power y, n equals to 1 minus 2x squared e power y. Now we find the partial derivatives of m with respect to y. So this answer will be minus 4x e power y as x considered constant. Similarly, del n del x, we find the derivatives and partially with respect to x. So this will be minus 4x e power y. So we can see that del m del y is equal to minus 4x e power y is equals to del n del x. So the equation is exact. So equation is exact. So next we will solve this exact equation. Now we find the integration of m with respect to x. So our m is here, integration step 1, step 1, integration of m with respect to x. What is our m? M is minus 4x e power y dx. So we find the integration of this with respect to x, it will be minus 4 e power y x square by 2. That means it will be minus 2 x square e power y. In the second step, we have to look at the term free from x in n. So our n is here. Here 1 is the only term which is free from x. So in the next step, we find the integration of 1 with respect to y. So since our n is 1 minus 2x square y, so here free from x, here free from x is only 1. So we find the integration of 1 with respect to y, so the answer is y. Now finally we can add these two answers. Finally our integration of m is minus 2x square e power y minus 2x square e power y plus y is equal to arbitrary constant. So means that y equals y minus 2x square e power y is equals to c1. So this is our answer. Finally, we consider one more examples to complete this method. So we consider the following equations. This is the exact equation already mentioned in the question. We have to solve this equation. So here we can see that m is equals to 2x y squared plus 3x squared, n is equal to 2x squared y plus 4y cubed. So you find that the partial derivatives of m with respect to y, so it will be 2x times 2y is equal to 4xy del n del x is equals to 4xy. So we can say that del m del y is equal to del n del x. So the equation is exact. Now we will solve these equations. Step 1, integrate m. Here m dx. Here m means 2x y squared plus 3x squared dx. So integration of this is equals to 2x squared by 2 y squared plus 3 into x cubed by 3. So when we simplify this one, we get x squared y squared plus x cubed. In step 2, we have to see which terms is free from x in n. So now in n, we can see here these terms having x, so you don't need to take these terms. So these terms without x. So we have to integrate this one with respect to y. So that means for y cube dy is equals to 1 by 4 y to the power 4. That means is y4. So our general solution is, hence our general solution is x squared y squared plus x cube plus y to the power 4 is equals to c. So this is our solution. So I hope all of you understand. So in the next video we will discuss how to solve first order differential equation using Bernoulli's methods or using homogeneous system of equation, that means by substitutions. So wait for the next video. Thank you.